physicists, okay? And they're now transacting international global capital. Das Kapital lives in their skills. Now, I want to show you something that's the bottom line. Great latency equals great location. Now, here's a really bizarre and dramatic story. Okay, there's this place called the New York City Carrier Hotel. Now, it's a place where algorithms check in, but they don't check out. And I've given you two little references here. Maybe Frank can distribute this stack at the end so people can view them later. But this is a really dramatic story. The Carrier Hotel is where AT&T, back in the 70s, laid all their dark fiber. Okay? And it's the New York City, it's the entry point of the internet into New York City. Now, AT&T divested and they created this Death Star symbol. This used to be called their Darth Fiber. Okay, that's all this Death Star motif, and they had all these little crazy games on the Star Wars angle. But AT&T never had a business plan to sell this dark fiber. So eventually they sold the address, which was this hotel, to New York City. And unfortunately, this hotel became a place where challenged communities were set up to be given shelter by the city, like homeless people, people who had drug and alcohol problems. They were set up there. But at any rate, let's see what happens in the 80s and 90s. Something very interesting happens. Okay. Now this is a geophysical map of 7 of the largest sell-side investment banks in New York. Okay. Now what's more important is the relationship of these banks to the Carrier Hotel. Because remember, the Carrier Hotel is where the internet enters New York City. Homeless people, alcoholics, crackheads, they're there now. Okay, but watch what happens. Okay, superimposed over the addresses of these elite and prestigious sell-side investment banks are their algorithms. This is where their algorithms live. Now, one of the physicists who sponsors the Cherokee Nation algorithm at Goldman, okay, he had a problem. He said, given that the international price ticks are coming through the plumbing of the Carrier Hotel, Barclay's Carnival algorithm is getting an 80 microsecond lead on these price ticks. They're getting them 80 microseconds faster than us because they're that much closer to the Carrier Hotel. So the Soviet physicists at Goldman went to their management and said, is there any way we can beat Barclay's advantage because they have a physical advantage? Well, you won't believe what they did. They checked into the Carrier Hotel. So amongst alcoholics, crackheads, and homeless, the elite of the elite, Goldman Sachs tears down a floor, introduces all new air conditioning, reliable plumbing, turns on air conditioning for all the tenants everywhere, says we want our algorithm here because we don't want Barclays to have 80 microsecond advantage. And that's an amazing story. If you go back to this link here, look up this story by Kevin Slavin. Okay, it's a great story. He tells the whole story in very elaborate detail. But anyway, going further, eventually Citi and Deutsche Bank found out that Goldman went to the Ma Bell plumbing place, and now all the algorithms now live at the Carrier Hotel. Only in New York, right? So, all right. But that's a great story, I thought. Okay, here's a bottom line. Okay, caching efficiency can be measured like this. If your hits are in your cache are a high percentage of your total hits, then you have an efficient cache. That's the bottom line. And when you have high efficiency, you can offload the database a great deal, and you can get great performance. Now the question is, how can we best make this happen with Java caching technology? All right, I don't know about a lot of you guys, but I found Java technology to be pretty delinquent in terms of capital markets use cases. I mean, we have Java caches that house reference data. We have Java caches that host treasury benchmarks. But high-frequency price ticks, okay, those are still delegated to proprietary systems with million-dollar licenses we have to pay. And because Java's delinquent in being able to meet those demands. All right, let's move forward. When you have a distributed cache, we're talking about L1 and L2 and where your caching resources sit. When you have caches that are partitioned and distributed, you have to have what's called a coherency protocol to keep the caches consistent. All views on what the cache contains have to be consistent, okay? they have to be available, and they have to be tolerant to partition failure. Okay, and that's very important because all three of these things have to be present in some form. Now, there's trade-offs you have to make, but one thing I want everyone to be aware of is don't ever let a caching vendor tell you that they can sell you something that's simultaneously consistent, because it's physically impossible. And it should be a red flag if they try to do that, because they can't do it physically. There's this theorem in computer science called Brewer's theorem, and it's been abbreviated to be CAP theorem. Professor Brewer from Cal Berkeley said that he had a conjecture that for a distributed computer system, it is impossible to simultaneously provide consistency, availability, and partition tolerance. Now, let me just give a quick example of what's meant by that. Okay, let's say I want to start a simple caching service. Okay, Ben's going to start a cache. It's a birthday reminder service. Okay, you call me, okay, at t=1, and I'll write down on my ledger the name of the birthday you want me to remember, the name and the date of birth. You call me back at t=2, and I'll give back to you that information that you gave me earlier, okay? This system lacks availability, because what if two people call me at the same time? Now, to solve the availability problem, I hire my ex-wife, okay? So now if you call the service, I'll put the name in if I get the call, and she'll put the name in if she gets the call, and either way we'll give you the name back. But this lacks consistency, because what if at t1 you call me, and I put the name in my book, and you call her back at t2, but she doesn't have the name in her book yet, because it's not consistent, okay? The views of the data are not consistent. So me and my ex-wife add a coherency protocol to this system, okay? We say this: we're not going to have individual books, we're going to share the book, okay? So this way we have consistency and availability. We think we're going to have a good service now. Of course, me and my ex-wife inevitably will get in a fight. She'll stop talking to me, okay? So our elegant coherency solution is useless. We have a partition failure, okay? She's not going to talk, and there's nothing you can do to fix that. So how do caching vendors overcome Brewer's theorem? You can't simultaneously provide all three. They do it with what's called eventual consistency. So you want to hear their specifics of how do they implement eventual consistency. They want to know, can you promote to strong consistency? How do you do this with local transactions, explicit locking, XA transactions, etc.? And if you go further down the compromises, you can say, do you have any notion of partition healing, like sort of like counseling? Like the partitions can reconnect and rejoin and be healthy. So they cannot possibly sell you this as a simultaneous solution. Computer science says it's impossible, and computer science is correct. Okay, let's look at briefly at some of the existing APIs that accommodate Java caching. Okay, Hibernate as a technology. To be honest, I'm not too super familiar with JPA and DAO. Okay, I know this. Hibernate is often, you use a caching vendor solution to act as an L2 cache for Hibernate. You know, you have your object model, you have an L2 cache, and you have Hibernate's backend, which is typically a relational data store, some kind of system of record. Hibernate plugs in well, but it didn't used to play very well with clustered partition caches. Hibernate 3 now includes something called the Cache Region Factory in their service provider interface. This goes a long way to making Hibernate very strong in terms of supporting distributed caches and clustered caches. Okay. All right. Well, enough now of the theory of caching. I want to move on to talking about JSR107, which is the new standard Java caching API. All right. Now, before JSR107, all the caching vendors provided basically proprietary APIs. Okay. If you wrote caching code, your code suffered from vendor lock-in. Now, just like JDBC solved this problem for the RDBMS community, JSR107 solves this problem for the JCache community. Okay, so imagine writing to Oracle's proprietary data API or Sybase's TDS, or imagine writing directly to CTLib rather than JDBC or whatever Oracle's proprietary mechanism is. You're writing to a vendor's lock-in. Okay, so JSR107 gives to the caching community what JDBC gave to the RDBMS Java community. JSR107 is completely open. It's typically the Java community process requires its expert group to communicate privately on a private jcp.org expert group forum. JSR107 is completely different. We're hosted publicly on the Google Groups at that URL. It's a public expert group forum. Every flame we ever had with one another, every whim we ever thought of, every notion, every musing is publicly documented. Okay, looking at JSR107, we introduced a new package hierarchy. We have javax.cache. That's now going to be available to you. The central interface is called cache. JSR107 develops. We use java.util.serverloader, which is only available in Java 6. So Java 6 is required, Java 6 or above, okay? JSR107 is going to be in Java EE7, which is due at the end of 2012. So if you have a favorite EE container, WebLogic, JBoss, if that container becomes EE7 compliant, it's going to have JSR107 as an implementation in its offering. And if you're willing to take down like a reference implementation and use Java EE6 or Spring, you can start using JSR107 immediately. Okay, and it's usable like any Java-based app, okay? What's that? Okay, the specification leads, okay, are Oracle and Terracotta, okay? But to be blunt, there's a whole universe. Well, one thing about JSR107, it has 3 members of the expert group who are directly from Wall Street. I'm looking now to see David Mazakowski from Citigroup. David sits on JSR107. I represent Credit Suisse. And Billy Newport from Goldman Sachs, all sitting in there. We sit there and we pretty much throw tantrums in the community forum about your delinquencies. All right? And we're telling the big players. We're telling it to IBM. We're telling it to Oracle. We're telling it to Terracotta. We're telling it to Red Hat. We're saying, look, Java is not a significant player for our use case. If you accommodate our use cases with something that's sound and complete, we promise you we'll be your best customer. We're everybody's best customer once you satisfy us. Okay, so it's being pushed by a lot of angles. Everyone's tired of auditioning and caching providers and writing their own facades to delegate to the proprietary APIs. We're sick of it. It's a delinquency in the Java community. It's shameful. So we want to give some incentive to these caching providers to write a standard. So maybe there's a